Okay, third and last time we're going to go over this. This time we have some blanks that we're going to fill in together. Okay, so let's start with how the brain learns. Fill in the blanks. A, our brain. Some information out of the brain. It's about how many centimeters long? 15. Okay. It's about the size of 2 fists. It weighs 1.5 kilograms. Excellent. Write that down. It is made up of cells called neurons. Excellent. Write it down. This is how the neuron looks like. These little things are called neurons. Write it down, the box. And this little thing here is called axon. Write it down. And these little fellas here are called
Dendrites.
Huh?
Dendrites.
Dendrites. Excellent. Write it down. Dendrites. Okay, no. We're still here. What happens? Information is stored right here, Sam. Information is stored right here. How does it get here?
Through the axon, then the synapse.
Okay.
Then to the dendrites.
Dendrites. What is this space called right here?
Synapse.
Synapse. Okay, great. Thank you. So this little space here is called a synapse. Excellent. Okay, next. Growing dendrites. We said as we learn, our neurons grow dendrites. So the more we practice, the better we learn, the more dendrites we have, therefore forming more connections with other neurons. As new learning occurs, our neurons grow dendrites. These dendrites connect with what of other neurons?
Axons.
Axons of other neurons. Excellent. Relating new information with previous learning and memories. The more branches or dendrites and the more connections we form with other neurons, the better our learning and the stronger our memory. So the more dendrites we have, the more connections we have, we learn better and we remember longer. Connections are formed through small spaces called synapses, excellent. And are carried by neurotransmitters such as dopamine. Okay, excellent. D-O-P-A-M-I-N-E. Dopamine. Excellent. Okay, Nina, on this diagram right here, where would the neurotransmitters like dopamine work? Inside the neurons, in the axon, in the synapse, or in the dendrites? Where would they be acting? Connecting what and what?
Connecting the axon to the dendrites.
Excellent. Through the
Synapse.
synapse. Excellent. Okay, great. Number 4, our memory. We basically have 2 types of memories. We have which is called the working memory or long-term memory. Okay. Now, how many inputs do we have? Look at me. How many inputs do we have into our working memory? How many inputs?
7.
No, how many inputs?
3.
3. And how many outputs? 2. How many distinct pieces of information can we?
7.
7. So write 7 right here. We can only hold 7 distinct pieces of information at a time. For ages?
14.
14 and over. Great. So what gets into our long-term memory is the information from the working memory that becomes stored. What gets out of the long-term memory is the information that we need to retrieve into our working memories to work with. So say for example you have a math problem that needs to be solved using a certain equation or a certain formula that you know in your long-term memory. Now you have the problem in front of you, it's on your working memory, on your desk, right? What do? You retrieve the formula from your long-term memory, put it on your desk, on your working memory, and use it to solve the problem. Does that make sense? Okay, what gets into our working memory? First, the information we retrieve like we just said. Second, information from the environment. Third, information from inside our brains. What gets out? Either things that are good, which are being stored in our long-term memories, or things that get lost because of too much information on our working memories. Growing dendrites, we already spoke about that. Did you all write it here, everything here? Okay, great. Okay, let's go on to the next one. Now, we talked about what gets in first. We said that the first thing that gets in is data affecting survival. Excellent, survival. Then data generating emotions, feelings. And finally data for learning. Great. gets stored? Things get stored that have sense and meaning. Okay, what is it? Is this called sense or meaning? Sure? Okay, so write sense. Why is it that way? Or why do I need to know this is called meaning? I need to attach sense and meaning to the information that I'm learning in order to make it easier to be stored in my long-term memory. If it doesn't make sense to me or it has no meaning to me, it will probably become lost very easily. Okay, now we talked later on, we talked about our two types of brains. We talked about our reactive brain and our learning brain, or thinking brain, okay? Now, what is the name of the first filter here? It was made up of three letters. RAS, reticular activating system. And then there was something else what they called the amygdala. Who remembers the spelling? A-M-Y-G-D-U-D-A-L-A. Excellent. Amygdala. Now, the information that goes to our reactive brains is when we either feel stress, danger, or boredom. Excellent. It goes to our thinking brains if there is interest in what we're doing, novelty, something new, or relevance. Okay, great, relevance. Okay, can you explain to me, please, what relevance means?
Something that is relevant to me, or either personally or.
Okay, great. So something that is important to me, something that is relevant. Thank you so much. Okay, reactive brain only knows how to do three things: fight, flight, excellent, or freeze. Great. Write it down. Okay, learning brain. Prime time and downtime. Prime time is when we are learning the best. Downtime is when we are learning the worst. Prime times increase in shorter learning episodes. If I have a short learning episode, I have a lot of prime time. If I have a long learning episode, I have a lot of downtime. So always make your learning episodes as short as possible. Example, a 20-minute learning episode has how many minutes? 18 minutes, which is 90%. Excellent. And a 40-minute learning episode has 30 minutes of prime time. 75. Excellent, excellent, excellent. Okay. Then we talked about something called the primacy. What effect?
Efficiency.
The primacy. Okay, I'll give you a hint. Starts with an R. Recency. Yes. The primacy, recency effect. The primacy, recency effect. Primacy means primary, first, and recency means the most recent, which is the last. Okay. We remember best that which comes first, then that which comes last. We remember the least, that which comes just after the middle. Excellent. This means that we should gain information at the beginning of a learning episode and reinforce, summarize, revise that information at the end of the learning episode. Use the middle of the learning episode for practice, because that's when I have a lot of downtime, if you want to call it that way. That's where the primacy recency effect shows that we don't learn that well. So use that for practice. Don't try to put new information into your brain in the middle of the learning episode. Then we talked about our brains as the novelty seekers, and we said that our brains always pay extra attention to what is novel. And novel means
new or
different. Great. A predictable environment, something that we know what's going to happen in exactly, lowers the brain's interest in the outside world and focuses the brain within. This is something good for studying. What is bad for learning in the classroom. Okay, really quickly. So, look at me, don't look at the papers here. Our brains are basically made up of little cells called neurons. Great. Okay, one more question. A neuron, every single neuron has two things. It has something called an axon and things called dendrites. One neuron connects to the other neuron. If one neuron connects through its axon, it connects to the what of the other neurons? The dendrites. The dendrites, exactly. There's a little space, a little gap between the axon and the dendrites, called them synapse. In this synapse, there are things called neurotransmitters which transmit the information from the axon to the
Dendrite.
dendrites. Give me an example of a neurotransmitter that we talked about. Dopamine.
Dopamine.
Excellent, dopamine. Okay, very good. Then we talked about our memories, and we said we have something called a working memory, something called long-term memory. How many pieces of distinct different information? 7. Can we hold at a time if we are ages? Okay, if we're under 14, do you think we can hold more or less?
Less.
Less. Okay? Less. So if you take a 6-year-old or a 7-year-old, it's hard for her or him to memorize a 7-digit telephone number, but it would be easier for you. Okay? Then we talked about the inputs and the outputs in our memories. We said our working memory, our desks have how many inputs? 3. We have information from information from our brains and things that we retrieve from our long-term memories. Excellent. And we have 2 outputs. One is something that goes to the long-term memory, storing. So that's the information that we're storing. And second is lost, things that we lose because it's too much for the working memory. Great. Okay. What gets in first? Let me ask you this question. Wait till the end of the question. What gets in first? Okay, into our brains. What do you think? Number 1. Is it the fact that the area of a circle equals pi r squared, or the feeling that I am hungry, really hungry, or the memory of someone I love who has just died very recently? Which is the first one that gets into my brain? Hungry, because this is beta affecting survival. Then emotion. The person I'm sad for. Okay, and finally, okay. Then we talked about something else, and we talked about when I want to store information in my brain. Okay, for you, you're studying, you're learning. Now your teacher isn't doing anything to help you. Okay, you help yourself. I want to store this information. I want this information to be remembered. I should attach to it 2 things. What are they? Sense and meaning. So I shouldn't listen to a teacher and just try to know what he's saying, just try to memorize it. I'm going to have a hard time. I may not remember afterwards. Okay? If I want to really remember and have this memory and understand it really well, I should first know the sense of it, which is what it is. So I really need to ask questions, read, do whatever you want, discuss, try to reach that you have sense of what it is. You know what this is that you're learning. And second, why is it that way? Okay, give it meaning. Okay, why is it the way it is? Now, if you really can't know why it is the way it is, then why do I need to? Why should I learn? So, for example, we said an example a little while ago. We talked about the solar system. So you learn that the planets revolve around the sun in orbits that are shaped in the shape of an ellipse, which is not a circle. Okay, an oval. Exactly. Now, this is a fact. You're going to remember it, but you may not remember afterwards that it was an ellipse. You may think it was a circle. So, if I want to remember this fact, what do I need to do? First, make sense of it. Know what an ellipse is, what an oval is, what does it look like. So, if the teacher just tells you, the orbit around the sun is an elliptical orbit, not a circular orbit. Don't just say, okay. You need to understand what an elliptical orbit looks like. What is it? Okay? So, what's an ellipse? It's a circle that is a little bit longer on 2 edges, like it's an oval, okay? Exactly. So now I know it's an ellipse. That's a sense. It's an elliptical orbit. Second thing, why is it an elliptical orbit? Why does it look like that? Why is it not circular? If you can understand this, you'll never forget that it is an elliptical orbit. Okay? So give sense and give meaning. Okay. Great. Who can remember without looking at your handouts what it is we said after the slide that said that we attach sense and meaning? Excellent. Our 2 brains. Our 2 brains. At the very top here, there were 2 words right after each other, the filters. One was called the R, and the other one? Amygdala. Which one was on top, RES or amygdala? RES. Okay, great. Then I had a thinking brain and a reactive brain. Which one was here? Which one was here? Excellent. How do we go to the reactive brain? If we feel stress, boredom was number 1, 2, or 3? Okay. Our reactive brain's right here. Did it have anything here on the slide that was yellow? A smiling face? Sad face. Where was the sad face?
Here.
Great. So, what can this reactive brain, the sad face, do?
Freeze.
Or freeze. Excellent. What about the thinking brain? What can it do?
Learning.
Learning. Excellent. Smiley face. Okay, what were the three things here that lead to the thinking brain?
Novelty.
Novelty.
Interest.
Interest. Relevance. Was relevance number 1, 2, or 3?
Three.
Also?
Yes.
Okay, great. What was afterwards? No, what was after that? What was the page after that?
E-learning.
The learning brain. The learning brain. Wow, excellent. Okay. Looks. He has it on the back, so he didn't cheat. Good job. Okay. So, B, the learning brain. And when we talk about the learning brain, we talked about something called prime time and downtime. Prime time is when we learn the best. Downtime is when we learn the worst. If we have a very long learning episode, are we going to have a lot of prime time or a little prime time? A little prime time and a lot of downtime. If we have a short learning episode, we have
A lot of
prime time and a little downtime. Excellent. Okay, so you now have a chapter to study for physics, for a physics test tomorrow. Okay, and your chapter is made up of 20 pages. Okay, each 2 or 3 pages is on a certain topic, and there are certain questions on these 2 or 3 pages. Meaning that you have to study about, let's say, 6 or 7 topics. Let's say 7 topics. Okay, 3 pages each, so that's 21 pages. Each of the 7 topics has some questions on it. What would be best to do? To sit down for 3, 4, 5 hours, study the whole chapter, 7 topics after each other, and then go to sleep? Or divide my learning into each topic in a shorter learning episode? Divide each one into shorter learning episodes. Okay, later on we talked about something called the primacy. You're forgotten first.
Recency.
Okay, so I'll remember it now. Primacy recency effect. It says that we learn most of that which comes at the beginning, and then that which comes at the end. And we learn the worst, or we remember the least,
The middle.
just after the middle. Excellent. So now you're going to break down your 7 topics into 7 short learning episodes. Let's say 20 minutes each. 20 minutes will give us how much prime time? 18 minutes, which is how much? Okay, if I would take each 2 together, so 40 minutes. How much prime time?
30 minutes.
75 minutes. Excellent. So we're going to break down each of the 7 topics into 20-minute segments. Okay? Sound good? Now, in the 20-minute segments here that you have between, for every topic, what is the best way you think I can study the topic that I need to study? Now, I'm going to give each one of you, not each one of you, all of you, 1 minute to think. Okay? Don't answer except after 1 minute is over. When the seconds goes back to 2. Okay? And you need to tell me, how do you think you could study each of the 7 topics in 20 minutes the best way? What would you do first? What would you do in the middle? What would you do last? Take 1 minute to think. Stop. Now, before you tell me your answers, let me ask you a question. How many of you reached the answer that they are going to answer me well before the 1 minute was over? Raise your hands. Okay, great. So that's almost all of you. Afterwards, who thought about data affecting survival? Honestly. Who thought about whether they're hungry, thirsty, cold, or warm? Nobody. Who thought about the feelings they feel or their emotions? Nobody. 1. Okay, great. Who thought about what we're learning right now? Okay, excellent. Now, do you see what happened here? You were thinking about what we're learning now because you feel safe, predictable environment, you know everybody here, you know me, okay? You're probably not hungry or thirsty or colder or warmer. only one of you had some kind of problem, probably hungry or something, so that's why he was thinking of something else before he was able to focus on what we are learning today. Okay, who would like to tell me an answer about what to do with each of these topics?
Three important parts at first for 6 minutes,
Okay.
and the one similar to them last for also 6 minutes, and the least important part in the middle for 4 minutes.
Okay, great. So she took she divided the parts of the topic into little parts. And she took what she thinks is the most important to put it at the very beginning of her 20 minutes. And the ones that are important next, put at the very last 6 minutes of the learning episode. And then in the middle, she put what is not so important. Who would like to say something a little bit different? Go, sir.
First, I'd read the whole topic, then I'd practice through the questions given, and then I'd reread all what I've read,
Okay.
and I can correct my mistakes along the way.
Okay, so here he devised another plan. He's going to go over everything in this topic. All of the little points she divided, he's going to take them all at one time, okay, at the very beginning. And really, really focus, correct? And then he's going to do a lot of practice in the middle about what you already learned. Then after he finishes, he's not going to end by practice. He's going to do it all over again. Read it all over, study it all over again intensively with much focus. Great. Anything else different other than these two? Okay, so basically what did we do? We divided our learning into short episodes, and we divided this episode into 3 parts, a beginning, a middle, and an end. We focused the important information or the important studying into the beginning and the end, and we left the middle for practice. Okay, excellent. Last slide, last page. What was it called? The novelty seeker. Okay. And we said that our brains always look for what is new or what is different. And if we have a safe, predictable environment like our homes, for example, are we going to be able to study well? Probably yes, because our brains already know what is outside. Okay? Let's say you're studying in your room, for example. You know exactly the colors of the walls, the color of the furniture, everything around you. You know how comfortable or uncomfortable your chair feels. Okay, you're wearing comfortable clothes. You are in your comfort zone. Everything is predictable, so you can actually focus on what you are learning. But does that mean that if you feel bored or you feel stressed, that you're still going to be able to learn? No, it doesn't mean that. But at least from the outside, you have everything in order. In our classrooms, if our classroom is really boring, is that good or bad? Bad. Because we want stimulation from outside. We want our teachers to move around. We want our teachers to change their tone of voice. We want our teachers to stand on the desk, to jump up and down, do anything that will keep us looking, grab our attention. Okay, if you do activities, do things yourselves, then you have something new or something different every time you listen. If it's just boring, one way, one day, we start to focus within ourselves, and our reactive brains only can do one of 3 things. Fight,
Flight, freeze.